Every threat we've covered so far in this series gives off something. An asteroid reflects sunlight. A solar storm arrives as a burst of plasma. A gamma ray burst is, quite literally, made of light. A supernova outshines its entire galaxy. A rogue black hole gives off none of that. It emits no light, no radiation, no signal of any kind. It is, by definition, the one object in the universe designed to be invisible. Somewhere in our galaxy right now, there could be hundreds of millions of these things, drifting silently through the dark. And for most of history, we had no way to detect a single one of them. So here's the question. This video is built to answer. If something is completely undetectable by every instrument we have, is there anything left to actually survive? And the answer starts with a discovery that only happened a few years ago, and that most people have never heard of. Welcome back to Space Won't Win. We've deflected an asteroid, braced for a solar storm, outlasted a beam of light with zero warning, and watched the sky for a star that might one day die too close for comfort. This episode takes the one thread in the whole series that sounds truly unbeatable and asks whether that's actually true. If you haven't seen the earlier episodes, go watch those first. The pattern that's about to click into place will hit a lot harder. Subscribe now, because this is the strangest survival story we've told yet. Let's get into it. A rogue, or isolated black hole, is exactly what it sounds like. A black hole that isn't orbiting a star, isn't feeding on a companion, and isn't sitting at the center of a galaxy. Most stellar mass black holes form the same way. A massive star runs out of fuel, collapses, and what's left behind is an object so dense that nothing, not even light, can escape its gravity past a certain point. Some of these stay bound to a companion star, and we can spot those because the black hole visibly pulls material off its partner, heating it until it glows in X-rays. A rogue black hole has no companion. It was either born alone or got violently kicked out of a binary system by the same supernova that created it. And it's been drifting through the galaxy in total silence ever since. No light, no X-rays, no signature at all, unless you know exactly where to look and how. Here's the breakthrough that changed everything. You can't see a rogue black hole directly, but you can see its gravity. When a massive, invisible object passes directly in front of a distant star, from our point of view, its gravity acts like a lens, bending and briefly magnifying the star's light in a very specific, predictable pattern. It's called gravitational microlensing. And in 2022, astronomers using years of Hubble Space Telescope data confirmed the first isolated black hole ever detected this way, roughly 7 times the mass of our Sun, drifting through our galaxy, about 5,000 light-years away. It took years of careful measurement to be certain, because this kind of event happens once, briefly, and never repeats. But it proved something enormous. The technique works. We can find the invisible. Here's where this thread is genuinely different from everything else in the series, and not in the way you'd expect. A single microlensing event tells you a rogue black hole passed somewhere between us and a background star, years ago, once, and it's already gone. It's a record, not a countdown. On its own, that's not a warning system for anything heading toward us. But astronomers aren't relying on catching one lucky flicker. Surveys like OGLE and the newer Gaia Space Telescope are constantly tracking the precise positions and brightness of billions of stars, which means the same technique that found that first isolated black hole can, in principle, be run in reverse, building a map of where these objects are and how they're moving, long before any one of them gets anywhere close to us. And there's a second, quieter warning system already running, almost by accident. Astronomers constantly track the orbits of objects in the outer solar system: comets, dwarf planets, icy bodies in the Kuiper Belt, and the distant Oort cloud. This is the same technique used in the ongoing search for a hypothetical Planet 9, looking for subtle gravitational tugs that don't match what's already known to be out there. A massive object passing anywhere near the edge of our solar system, black hole or otherwise, would leave fingerprints on those orbits years, potentially centuries, before it ever reached the inner planets. We wouldn't need to see it. We just need to notice that something out there was quietly nudging things off course. Let's talk about scale, because the honest numbers here are wilder than you'd think. Astronomers estimate there could be as many as 100 million stellar mass black holes scattered across the Milky Way. Most of them rogue, most of them invisible, most of them simply drifting. That sounds terrifying, until you remember how big the galaxy actually is. It's roughly 100,000 light-years across, and stars, let alone black holes, are separated by average distances measured in light-years. Even with 100 million of them out there, the odds of one passing anywhere near our solar system in the next few million years are astronomically low. Space, quite literally, is mostly empty space. And here's the important nuance. A rogue black hole doesn't need to collide with Earth to be a problem, because a stellar mass black hole is actually tiny, often only a few miles across. A direct hit is honestly the least likely version of this threat. What actually matters is gravity at a distance. If one passed anywhere near the outer edge of our solar system, its gravity could destabilize the orbits of distant icy bodies in the Kuiper Belt or Oort cloud, potentially flinging a wave of comets inward toward the inner solar system over the following centuries. If it passed closer still, near the orbits of the outer planets, it could measurably disturb them, and in an extreme, very low probability scenario, gravitationally perturb Earth's own orbit over a long enough timescale. The threat isn't a collision, it's a gravitational disruption that unfolds over generations, not seconds. And this is where the series starts folding back on itself. The most realistic danger from a rogue black hole isn't the black hole at all. It's the increased rate of comet impacts it could trigger decades or centuries down the line, which means the actual defense against this threat is the same one we opened this entire series with: detection surveys, tracked orbits, and a proven kinetic impactor capability, sitting ready for exactly this kind of long lead time nudge. We wouldn't be defending against a black hole. We'd be defending against what it stirred up on its way past. Let's be completely honest about this one, because it's different from every episode before it. There is no bug-out bag for a rogue black hole. No cash to stockpile, no sunscreen to buy, no shelter to build. If one passed close enough to our solar system to matter, the timeline would unfold over decades, potentially centuries, and the response would happen almost entirely at the level of institutions, not individuals. The same telescopes, the same tracking networks, the same planetary defense infrastructure we've talked about in every episode of this series, just pointed at a different kind of threat. Your personal survival strategy here is, genuinely, to keep living your life. That's not a cop-out. That's the actual science. What survival actually looks like at a civilizational level is continuity. Making sure the surveys keep running, the orbital data keeps getting logged, and the funding for observatories like Gaia and its successors doesn't quietly lapse because nothing dramatic happened this decade. This is a threat that punishes short attention spans. 100 million objects out there, almost none of them a real danger, means the only way this ever becomes a problem is if we stop watching long before it would actually arrive. The defense isn't a bunker. It's an institution with a long enough memory to keep looking at a threat that, statistically, will probably never show up in any of our lifetimes. And if the comet disruption scenario ever did become real, the playbook is one we've already covered start to finish. Back in video 1, detect it early, track its path for years, and use a kinetic impactor or gravity tractor to nudge it off course while there's still time. Nothing about a rogue black hole invents a new survival problem. It just potentially hands us an old one, a dangerous comet, with more warning time than almost any natural version of that threat would ever give us, because the gravitational disturbance itself would be visible decades before any single object became a real danger. Here's the genuinely reassuring part to close on. The overwhelming likelihood, based on everything astronomers currently understand about the size of the galaxy and the population of these objects, is that a rogue black hole will pass through our solar system's neighborhood roughly never on any timescale that matters to human civilization. The 2022 discovery wasn't a warning. It was a proof of concept, a demonstration that if one ever did matter, we now have a genuine method for finding it. That's the actual headline of this episode. Not, "There's an invisible killer out there," but we built a way to see the invisible, and it works. Every year, surveys like Gaia add more data, more confirmed detections, and a clearer picture of where these objects actually are and how they move. The map isn't finished. It may never be finished, but it gets more complete every single year, which means our warning time, if it's ever needed, only grows. This is a threat that gets less dangerous the longer we pay attention to it, which is the opposite of how most disasters in this series work. So here's what makes this episode the strangest one in the series so far. Every other threat we've covered gave us something to work with: light, radiation, a flare, a flash. This one gives us nothing at all, by definition. And we found a way to see it anyway. Not by looking at the black hole, by looking at everything around it. The light it bends, the orbits it nudges, the small, quiet fingerprints an invisible object leaves on a universe it can't help but touch. That's the real theme of this entire series, and this episode makes it plainer than any before it. Space doesn't need to be visible to be beatable. It just needs us to keep watching. Space won't win this one either, not because we can see it coming in the traditional sense, but because we built a way to notice it anyway. So there it is. The most invisible threat in the universe turned out to be one we already have a working method for catching. Did you know we'd actually detected one of these before this video? Let me know in the comments. And in the next episode, we're going back to something that started this whole series, but with a twist. Asteroids, we track for years. Comets are different. They spend most of their existence in the freezing dark beyond Pluto, and some of them could already be falling toward us right now, completely undetected, arriving faster and with less warning than almost anything else in this series. Is there anything we could actually do about a threat that might give us only months or even weeks? Subscribe so you don't miss it. Space won't win.